guided classes. And then what we have is the final thing called as runtime schedule clause. It is the case wherein um, any of this can happen at any instant. Most of the time it's just the static run and the schedule clause that happens. But in case if you want a situation wherein static or dynamic or guided, any one of these three has to happen automatically on its own at the runtime. I mean, you don't specify this has to happen, but in every example it should have any one of these three things should happen on the run. Okay, then runtime, that's how runtime clause works. And how that works is using external variables. Suppose if we have external variables like okay, let me write this down. Let new page after. Suppose if we have environment variables such something like OMP schedule. If you're working this in Linux or Unix, if you're having environment variables, then if you create an environment variable such as named as OMP schedule, then you can set this OMP schedule to values something like static or dynamic or guided with the guided, and and then based on whatever environment value you give over to OMP schedule, that particular schedule class will be active. Okay, that's about it. That's about runtime. So runtime makes sure that you can specify static, dynamic or guided on the run, on the fly, for running programs, and that's about it. Now you might be asking, why is this necessary? Why should I not go with static class and that's it? One of the main reasons is because sometimes working with static classes and dynamic and guided classes have their own advantages and disadvantages. Static class has an advantage wherein the mapping goes serially, whereas in the execution order it happens kind of little erratic. In execution order is different than the mapping order, so it moves differently. Okay, as a consequence, what happens is that when you follow static classes, the threads in the beginning have more job when compared to threads in the stop. So T1 and T2 will have more job obviously when compared to T3 and T4. Depending on the whatever kind of chunk size you give, T1 and T2 will have more job when compared to T3 and T4 in a not so perfect situation. Dynamic class is such that it's kind of even, but in dynamic class, what happens is that the work sharing can become uneven. That's a downside. But the plus point of dynamic class is that, okay, if let's say if a particular thread is working on a particular part of the chunk where it takes more time to do when compared to some other iteration. Let's say I'm doing this iteration, and during this part, one particular part of the iteration chunk takes more time. Let's say more time when compared to the other. In that case, instead of being idle, okay. In that case, if I use a static class, let's say, then let me come up with a good example. Let's say chunk 2 is a bottleneck thing. This is a bottleneck, meaning this takes more time when compared to other chunks to execute. Now what happens is that if let's say chunk 2 is working, thread 2 is working on chunk 2, then all the other threads have finished their job. Even thread 2 is still working. All the other threads will be remaining idle. Chunk 6 will be still left untouched. Chunk 6 will be still left untouched because it's still working on thread 2. Whereas maybe thread 1, thread 3 and thread 4 they could have finished their job and they might be waiting idle. In that case, if any one of these thread goes and does chunk 6, then there would be less waiting time. So the program, when thread 2 is finished, the program would have been over. Something like that. Okay. In these kind of cases, dynamic class takes place. Dynamic class is useful because the allocation is random. As a consequence, there is no predefined mapping, so any thread has the right to capture do any chunk and take any chunk and do. So that's possible. In guided class, what happens? The chunk size itself is a big issue. Chunk size itself is sometimes a big issue. Now, sometimes what will happen is that what will happen is that maybe more threads have to be available at the end of the job, and one thread has to do a large amount of job, something like that. Okay, then the guided class will be useful. For instance, let's say you're already having parallelization on the top before this kind of a loop. You have some parallelization on the top, and in those kind of parallelizations, one of the threads finishes the job quickly and then comes below to do the do loop. If that being the case, that one which takes more time to finish, which finish the job earlier, okay, if that comes below and it starts doing one of the bigger chunks, okay, by the time it will be about to finish the bigger chunk, the remaining threads from the top would have finished their job, and they would have come below, and they would have started picking up the other smaller chunks, and they would be and within a matter of time, all of them would be in sync. All the threads would have been in sync. There will be less lag time between them. Okay, that's the ideology behind guided ones. Okay, so these are purely on the computational things. For all practical purposes, most of the time the static class itself is sufficient. But if you are very much concerned about the performance of the code on the nitty-gritty levels, on how if you're really miser and you want to cut down any lag times or something like that, then guided class, static or dynamic dynamic classes are very useful depending on the case. Okay, that's all I have for you guys in this tutorial. Thank you guys for watching. Hope you guys understood this. In next tutorial I'll come up with some other concept, and we'll go on with that. Thank you guys for watching, and I'll see you guys next time.